level at which we are going to start from. So good afternoon, everyone. I presume you can actually hear me loud and clear. So I want to start on this note that I welcome us all to ensuring safety in power system. This is a annual program that is actually organized by the Young Engineers Forum of the Nigerian Society of Engineers, Ikeja branch. It is for this year, I think we said it's going to be a 7-day skill acquisition training on power system. So I want to welcome you all, and I want to crave your indulgence that we should abide by the rules and regulations of the class. In this session, we are not going to do anything much, but we are going to cover a lot. We're not going to do anything much, but we are going to cover a lot. We are going to have an overview, which I also call the introduction of why we are gathered here today, this afternoon. And we're going to do the power generation safety. We're going to do the power transmission safety. We're going to do the power distribution safety. And I'm going to play a video of a case, real life case scenario. And then that will now bring us to the concluding part of our session this afternoon. It is said that where there is no rule or where there is no law, there is no offense. So it is on that note that I want to set some ground rules for our class. Now, number one is that it is expected that you mute your mic if you are not speaking, because when you unmute, it's going to interfere with our classes. So mute your mic when you're not speaking, and if you want to speak, you raise up your hand using the icon in the Zoom app. So when you raise up your hand, you will be asked to either unmute or to type your question in the chat room. However, if you have a question before the end of the class, you'll be asked to either unmute yourself to speak, and then if you don't want to forget and we are not allowed to ask, you can drop it in the chat room. I have my chat, I'm using 2 devices. I'll use the other one to actually check the questions, and then I'm going to attend to them accordingly. Again, if you don't, this session is being recorded, and if you don't want your video to be recorded, it is advisable that you put it off so that you don't put it on by mistake, and then you begin to have issues with us recording your video. So having said that, there is going to be a training feedback form which the branch will be sharing with us in the chat room. At the end of this session, it is expected that each and every one of us to fill this form. And please, as much as possible, I want us to be more interactive. It should be a discussion. You're going to learn from me. I am going to learn from you. Thank God we have people who are intermediate. We have people who are beginners. We also have people who are professionals in our midst. We are not disputing that fact. But please, let's not keep mute. Some of us will join and then we just drop our phones and we go to the places where we want to. No, this is a time that we should dedicate for this session. I assure you we're not going to spend much time, but the time we're going to spend are going to be quality time. So please do well to stay put. Glue your eyes on the screen. I'll be sharing my slide. I'm going to be sharing my slide. My slides are going to give you PowerPoints, but my explanation is going to give you power notes. So I repeat myself, my slide is going to give you PowerPoint, and my explanation is going to give you power note. While I await for your responses, I want you to tell me, what do you understand by HSE? I know it is health, safety, and environment, but what do you understand by it? So I'm looking at the chat room. The class has begun. So I'm looking at the chat room, waiting for your responses. What do you understand by the word health, safety, and environment? All right, I'm waiting for your feedback. I'm waiting for your feedback. Health, safety, and environment. You can make it brief if you're typing. Okay, it involves people, place, and planets. We have the 3 Ps, okay? Thank you very much, Miriam Titilayo. Barka de Salam. Okay, without a waste of much time, I want this class to be as interactive as possible that it can be. When we talk about health, safety, and environment, which is HSE, some used to add the second S, while some add another S. Some calls the other S, the second S to be security, while some calls the second S to be sustainability. Okay, Gabriel, say health and safety environment deals with safety of the people, environment, and equipment. Excellent. Ogenemaru, sorry if I didn't pronounce it very well. He said HSC, aside its regular meaning, it ensures you are aware of your workplace and your environment and your assessment about your work and how to go about carrying it out being safe. Excellent. It means being conscious of your environment with regards to your safety. Karina Desmond, thank you very much. Emeka says health, safety, and environment is simply safety measures put in place to ensure the safe livelihood of personnel, equipment, environment, protecting from unsafe acts. Brilliant. So this shows that we all have a basic foundation of health, safety, and environment. Now, I want to put it this way that health, HSE, stands for health, safety, that is HSES. HSES. Some people can call, you have different acronyms for it. Some people can call it QHSES. Some people can call it QHSSE. Some people can call it ESE. Some people can call it OHS. Whatever acronym it's being used, they are called the same. They stand for the same thing. But in this case, I'm going to use HSES. So HSES stands for health, safety, environment, and sustainability. So it is a comprehensive approach that we use by either organizing or ensuring the well-being of ourselves or the equipment that we use and putting into consideration our environment, that is the protection of the environment and the operations that we carry out at either our place of work or in our homes. Now, I want you to also note that health and safety does not really restrict you to just workplace. Health and safety also cut across your homes, it cut across the school, and it cuts across public places, both public and private places. So this afternoon, we are going to be considering ensuring ensuring safety in power systems. We're going to be considering generation, transmission, and distribution, which most of these, I think, have been discussed. I think from the first day that I attended the class, it was discussed in the group. And I want somebody to tell us in the group, what do you understand by the word power systems? I think it was defined on the first day What do you understand by the word power system? So I'm going to be asking this question again. What do you understand by the word power system? Thank you very much, Olubumi. Please kindly rename your device so that we can address each and every one of you accordingly. Xiaomi 23. Please rename your device. Okay, I'm waiting for your definition of power systems. Okay, while we're waiting for that definition, I want us to know that power systems are the backbone of modern infrastructure, which actually encompasses the process of generating, transmitting, and distribution of electricity to meet the societal needs. I remember on the first day, somebody made a statement and said that if you generate electricity and you do not transmit it to the end users or to the final consumers, then you have not done anything. Why? Because your production did not really meet the customer's requirement. So that is why it is very essential. Thank you very much, Emeka. You said power system is the assemblage of the various components from generation to transmission and distribution of power to an end user. Brilliant. Again, I want us to note that there is no correct and there is no wrong answer in this class. It is just that your perspective about what you're saying is different from my perspective. So I am very sure that if I ask you to unmute, you're going to give a reason for your response. So please don't feel shy. Don't be ashamed to give a response to our questions. And at the end, we'll all enjoy this session. So as I said, power system is essential. We cannot really overemphasize the set, or we cannot overemphasize the role of power system in the blockchain of power transmission, distribution, and even the generation. So if we talked about that, as Emeka has defined power system for us to be the assemblage, now you will agree with me, yes, that power system is actually a component of things coming together that actually has to do with power. And we say power is what? We defined power, I think, in the last class using a formula, and we also defined systems, and we brought this together. Now, having known that these are components that are brought together, ensuring the safety of these systems and people that operate it is critical to prevent accidents, ensuring reliable services, and protect both your personnel or even your colleagues and the public entirely. So you will all agree with me that component of power system, which comprises of the generation, the transmission, and the distribution. Generation, actually, I think we also have defined generation from our classes that we've had in the past 2 Saturdays. Generation is a process of converting various forms of energy. It could be, I think the olden ones that we use, it could be coal, it could be natural gas, it could be nuclear, it could be hydro, it could be renewable into electrical energy. So it's just the process of converting this form of energy into electrical energy. And don't forget, we have different forms of power generation, and which I have just mentioned them. And it involves the likes of power plants where electricity is being produced. So the place where electricity is being produced is what we refer to as power generation. I'm giving us these basics because I want us to start from scratch. Maybe we have people who actually miss out in the first class and the second class, and then you need to actually have this fundamental knowledge. Then we talk about transmission. Transmission is the high voltage transfer. I'm going to be using simple terms, simple languages, so that we can flow very, very well. Because I'm sure we have people that are, as we said earlier, the beginners, the intermediate, and then the professional. So transmission is just the transfer of or conveying of electricity from the power plant to the substation. Now, this is done using transmission lines, the towers, to carry electricity over a long distance. That is what we refer to as transmission. Then when we talk about distribution, we are talking about the final stage where electricity is delivered from substation to the end users. This could be your homes, this could be industries and business places. So it involves low voltage distribution lines and transformer. So it is important for us to note that safety in power system is one thing that should be taken with all seriousness, because it does protect the workers, it does protect the public space, it does protect the environment, and it even protects the equipment. And I can tell you that if you don't protect your equipment, definitely you are going to have nothing than please mute your mic if you're not speaking. Okay. Okay, permit me, sorry, I will be muting those that are interfering with us, and then I will be switching to, I'll be putting on my mic. So it also affects the environment, because this is very, very important that we protect our environment. And by so doing, we are minimizing the environmental impact of power generation. We are minimizing the environmental impact of power distribution, including managing emissions and waste product. So adopting a sustainable practice and technologies to protect both the natural resources and even the ecosystem is very, very vital. Having said that, I'm going to be giving some terminologies that we use in power system training, and some of the terminologies that I will be using in this class. Though I will still be coming much later to give us some terminologies again as it relates to health, safety, and environment. But these terminologies also deals with safety terminologies in power systems safety training for this class. So understanding key terminologies in health, safety, and environment are very, very key, and it is very essential for effective power system communication. Because if you do not understand some of these terminologies, when I'm going to be saying them, you'll be thinking I am speaking abstract. So I am bringing up these terminologies that are related with power system, and I am sure that some of the things I've mentioned in my screen are things that you are familiar with. So I will want somebody to tell us, what do you understand by the word arc flash in the chat room? So while we're waiting for the person that will tell us what arc flash simply means, I will be talking about lockout, tag out, which is the LOTO. When we talk about LOTO, we are simply talking about procedures or strategies that you have put in place to ensure that machines or equipment are properly shut down and cannot be operated or cannot be started up again before either a maintenance or a repair is being completed. So an example, let's assume you are carrying out a maintenance on an equipment and you need to do what we call log out, tag out. The acronym for that is LOTO. You must have been hearing the word LOTO, 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 LOTO. What LOTO simply means is log out, tag out. And what that means, LOTO, the acronym is for log out, tag out, lock out, tag out, LOCK, as you can see on your screen, lock out, tag out. Now, what that simply means is the ability for you to close a particular, let me give an instance. Let's assume you want to start an equipment or you want to carry out a maintenance of an equipment. So the possibility of you going to your changeover and disconnect the power supply in that distribution line gives you aid. Now, when you disengage it with the changeover, you use something to lock it such that another person will not come and say, why is there no light here? And the person puts it on. So these are things that we need to put in consideration, and that is what we refer to as log out, tag out. Thank you, Emeka, for the definition of arc flash. Arc flash are electrical sparkling produced as a result of loose terminal. Thank you very much. And what that actually leads to is it leads to fire, and that fire leads to burn, and it also leads to equipment damage. The top thing I mentioned there is PPE. And you can remember the day I came, during our opening, I did give an overview of what we're going to be talking about. And I talked about personal protective equipment. And I said it is one of the least hierarchy of control. And if you can remember, I will want to wait for someone that is going to tell me the hierarchy of control that I mentioned that day, because I remember I mentioned about 5 of them, and I want to see who can actually mention that for me so that I will see. So if you mention that, I'm looking at the chart. I'm looking at the chart to know that to know what you are going to type as regards the PPE. So PPE actually, as the name implies, is personal protective equipment. They are just equipment, or they are gadgets that you put on in order to minimize the exposure of your body to hazard that could cause you serious injuries, illness, or fatality in the power system. Now, you need to know that there are different equipments that we use, or there are different PPEs that are used for a particular job. Now, you cannot use an ordinary hand glove to go and carry out a task on the lines. You know, when we talk about lines, we are talking about the transmission of electricity from the generating part to the substation. So you need to also note that. So you don't just use any type of PPE and go and carry out a task. Then we talk about grounding. Grounding is a process where you connect an electrical circuit or equipment to the ground. The reason why you do that is to prevent electric shock or damage during a fault to an equipment. And sometimes when you want to carry out maintenance, you actually do what we call grounding. And I'm sure that must have been discussed in the class, or that will be discussed in the class. Okay, thank you very much, Gabriel. You talk about elimination, substitution, managerial control, engineering. Beautiful. Thank you very much, Gabriel. So these are the hierarchy of control. Now, when you talk about managerial control, this we call them administrative control. We say that there are different types of hazard. And when we talk about hazard, we are referring to anything that has a potential or that has the ability to cause injury. So, and if you cannot eliminate the hazard, what we say is substitute. And you can see that we have a substitution for power supply. Some people can tell you that I don't want to be on the grid, and they depend solely on solar or renewable power supply. So, and they are not connected to grid. I know of people who are not connected to the grid. And this is because they are substitute for the power. So if there is a substitute for what you want to do, then you just substitute. If you cannot substitute, then you use your administrative control. But before the administrative, we have what we call the engineering control. So engineering control usually comes before the administrative control. So after your engineering control, then you can bring in your administrative. Then after your administrative, then you go lastly to your personal protective equipment. And as I said earlier, it is the list of hierarchy of control. So having said that, we have what we call fault current. I'm sure you must have had fault current. As you can see the spelling on the screen, fault currents, which is the number 5 from the terminologies which I'm defining. It is actually the abnormal flow of electricity that usually occurs during short circuit or fault condition. This can cause equipment damage and it can pose serious safety hazard. So that's another terminology. Then we have HV, as the name implies, high voltage. And these electrical charges or electrical voltages or energy that has high voltage. I don't want to use voltage again to explain it. So when we talk about high electrical voltage, we mean electrical energy that has electrical energy at voltages that are high enough to inflict harm or living organism, to inflict harm on you, on me, on equipment, or the living organism around our environment. So HV, as I said, refers to the voltages. Now, who can give me some of the voltage? When we say something is high voltage, what are we referring to? What is the current in volts? Can you give me that, either in AC or in DC? So you can drop it for me in the chat room. I'm not an electrical personnel, but I think my engineers who are on the call are going to help us if it is correct or not. But I think from what I saw on when I was trying to find making some findings, they say voltages above 1,000 volts for alternating current. And they said, I think 1.5 or 2,000, 1.5 volts for direct current. So you can say that the current is high when you see that in those ranges, either 1,000 volts for AC and then 1,005 for DC. Then we have what we call isolation. Now, some of us, I'm sure this word is not new to us. When we talk about isolation, isolation in for those of in COVID during COVID-19, you have heard about people talk about you need to be in isolation. They isolated him, they isolated her. Now, this is not different from what we have in the power system. So it is just a typical process of physically separating electrical equipment from the power source. You are separating the equipment completely from the power source. This is to ensure it is de-energized and a safe work will be carried out on that equipment. So I'm not going to go into more details, but I think you are familiar with the circuit breaker, the transformer, and then the substation. Now, when you talk about transformer also, I think in the group during our in the WhatsApp group, one of our facilitators was talking about we need to, you can say something and I need to agree with you or to disagree with you. And he asked the question, can transformer be upgraded? Or he made mention of something about upgrading transformer, or I've forgotten, but I remember very well he was saying something about upgrading transformer. But one thing I know that actually transformer are actually used to step up or step down voltages. And whether it is going to be upgraded, I think my engineer can actually ascertain that. Then lastly, we have a substation, which is a facility in the electrical distribution system where voltage is transformed from high to low or the reverse using transformers, and where other important electrical equipment functions are performed. Electrical functions are performed. So having said that, we have other terminologies, which is overcurrent protection, insulation, electrocution, hazard assessment. So let me talk about hazard assessment. You know, we've defined hazard as anything that has the potential to cause us injury. Okay, alternating current, we have 11 kVA, 33 kVA, 66 kVA, 132 kV. Okay, kV, sorry, and then 330 kV. So at what point do we say they are actually high voltage for alternating current? So when it is 11 kV, we can say they are high voltage. So I was talking about hazard assessment. You know, from the word hazard and assessment, assessment is just a process of you checking up something or trying to check the process of something. So when we talk about hazard, it is the ability for you, it is the process of you identifying, evaluating the potential hazard in the activity that you want to carry out so that you can implement the appropriate control, appropriate safety measures to ensure safety of the activities that you want to carry out. Now, when we talk about safety, remember I said earlier, and somebody mentioned it mentioned the 3 P's that we have. It is not just about you. It is also about the equipment. So it is also about the environment. So, and that is why you need to do what we call hazard assessment. Then when we talk about risk mitigation, from the word risk, we also have mitigation. So it is a strategy and measures taken to reduce the likelihood and the impact of hazard in the activities that we want to carry out. So after doing your hazard assessment, the next step is your risk assessment. Now, the hazard assessment is you are identifying the hazard and you know that these things are likely to cause you injury. Then you talk about the risks. Okay, if drinking water can really cause me injury, or for example, if you are telling me that my system or my mobile phone is an hazard, how can it really affect me? If you're talking about the likelihood of that your mobile phone to cause you injury, you have started grading your hazard in risk. With that process is now called risk. Because you are now saying, okay, this thing is going to have great impact on me. This thing is going to have less impact on me. So I'm going to put this to us and so that you will understand. Working with 66 kV and working with 11 kV, which one do you think is more risky? Certainly, it is the 66 kV. Why? Because it has a high potential, or yes, it has high energy in it flowing. And that is why we talk about risks. So your risks also, you are going to weigh them. Oh, somebody say can't hear you again. Please confirm if you can hear me in the chat room. Okay, loud and clear. Okay, I think you need to check your device. Wisdom, Lawrence, please check your device. You need to, so that you can follow us. Thank you. So risk mitigation is actually the strategies that we use in order that or strategies or measures we use in order to reduce the risks that we are facing in our place of work or in our environment. Then we have safety data sheet. This one, mostly they are found around the documents or the chemicals that we are operating. And that is why you discover that any chemical that you have, there is always a label on it. So, and when we talk about safety data sheet, is a document that provides information on the properties of hazardous chemicals and how they can affect health and safety in the workplace or at home. So you need to take note of that. For those of us that are science students, okay, all of us should be science students. I remember very well we were told one of the rules of entering the lab, you don't eat in the lab and you don't drink anything in the lab. Because you can imagine somebody going into the lab and there is a content in a beaker and you assume that that thing is water. And meanwhile, it is tetraoxosulfate 6 acid, H2SO4. So that can be what? Dangerous. We have fall protection, we have emergency response plan, and then we have confined space. Let me talk on this confined space. Confined space is actually a place or an area that is not designed for continuous occupancy. Confined space is not a place for you to stay. Confined place is not a place, it's just a place for you to go and carry out a task and then you leave. And that is what is referred to as confined space. Confined space. Then we have energy isolation device. I have given an explanation on isolation, and this is, I think they are interwoven. So when we talk about energy isolation device, we are talking is a mechanical device actually that physically prevents the transmission or the release of energy, such as disconnect, I think disconnector or disconnect switch, and we have circuit breaker or valve. So mostly valve are also used for the flow of energy, either water or steam. So mostly that is what we use to for energy isolation device. We have types of power plants, and I said earlier, we have the thermal power plants, we have the hydro power plants, we have the nuclear power plants, and we have the renewable power plants. So basically, I'm going to talk little about the thermal power plants, and then I'm going to talk about the safety of, I'm going to talk about the thermal plants, I'm going to talk about the hydro, and then I'm going to talk more on the renewable. The reason why I'm skipping the nuclear power plant is because I don't know, but you can tell me in the chat room if we have a nuclear power plant in Nigeria. So maybe I will also have to make my research. But if you know that we have any power plants in Nigeria that has their power generation is nuclear, then you can let me know. Okay, Emeka said none at all. Okay, but I'm sure we have thermal, we have hydro, we have renewable. In fact, thermal, I think thermal and hydro work hand in hand in a way. So when we talk about thermal, we do not have nuclear plants in Nigeria. It won't be bad to know more about nuclear. Yes, it's not bad. Okay, yes, I will give you peripheral knowledge about it, even if it is not in Nigeria. Okay, thank you very much, Ibrahim. I will give you the surface, but the in-depth. The reason why I'm saying this is because when you go to plant, I need to give you some of the safety things or some of the okay, I think I will give you some of the details as regards that and tell you some of the components of the nuclear power plant, and I will tell you some of the hazards that are associated with it, and I'm going to give you also the safety measures that needs to be put in place. Then when we talk about the thermal power plants, it's actually plants generate electricity by converting heat energy into electrical energy. Don't forget, we talk about converting different forms of energy into electrical energy when we were defining our generation of power plants. So when we talk about thermal power plant, I said it's just a way or a process of generating electricity by converting heat energy into electrical energy. The common fuels include either coal, natural gas, oil, or biomass. Some of these are the fuels that are used as a thermal power plant. Now, some of the components of these thermal power plants include boiler and turbine. Don't forget, every generation has turbine. They must have a turbine, they must have a generator. So these are the two common components that are in all of these. The only one I think that do not have is just the renewable energy. So the components associated with thermal is the boiler, we have the turbine, we have the generator, and then we have the condenser. Now, the boiler boils fuels to produce steam, while the turbine, it is being driven by the steam that is being generated by the boiler, which generates the electricity. And then the generator converts the mechanical energy from the turbine into electrical energy. And what happened when the steam has gone into the turbine to rotate the turbine, it cools the steam back into water for use again. Condenser, that's what condenser does. Now, you can see the process of this power generation I don't want to dwell much on it. Where I think I want to focus on is hazard. The hazard that are associated with this type of generation, they are high temperatures. High temperature, high pressure, boiler explosion, chemical explosion, fire hazard. These are the most and the common hazard that are associated with thermal power plants. High pressure, high temperature, boiler explosion, chemical explosion, and fire, in fact, fire incidents too. These things are more, they are common in thermal power plants. Now, what are you expected to do when you find yourself in such places? Number one is for you to carry out regular maintenance. I don't know if you have, I have witnessed one boiler explosion back then, I think as way as 2009. That was in Kainji, not Kainji Dam. Is it Kainji? Okay, Kura Falls. It is called Kura Falls. That is found in Plateau State. It is a private-owned power generation company. We actually went there on an excursion, and I think the day we were supposed to, we went there for an excursion the first day. So we were supposed to carry out our inspection and excursion the following day. So we arrived there a day before our excursion. And lo and behold, we heard about the explosion of the turbine. It was really a big one. And I can tell you from where we lodged, we heard the sound. And if you see the pieces of, if you see the way it pieces metal, you won't believe that it was a pressure from that boiler. So it is very risky. So some of the risks that is associated or hazard that is actually associated with such is the pressure that is actually in the boiler. So some of the safety measures that you need to put in place is regular maintenance, because some of you will find yourself in some of these organization or generating plants in Nigeria or even outside Nigeria. So the safety measures that you need to put in place, one, I said, is what? Regular maintenance. Two, proper PPE. Remember, PPE is actually necessary for all the types of power plants, all, even in distribution, even in transmission, you need the PPE. So I will be mentioning PPE most often. So, but also note that it must be the proper PPE that is used to carry out such operations or activities. Then the safety measure again that you need to also put into consideration is emergency shut-off system. There should be an emergency shut-off system. Now, I think in those days, most of the emergency shut-off systems used to be manual, but thank God for IoT, Internet of Things, and technology, we now have automatic emergency shut-off system. Then we have fire safety protocol. Some people mostly wait for incidents to happen before they try to implement health, safety, and environment. You see, there's in this part of the world, we are more of preactive. How do I call it now? We have proactive and we have reactive. Okay, we have proactive and we have reactive. But in this part of the world, we are more of reactive until something happens before we can put some things in place, which is very, very wrong. And those that are going to change the dynamics of things that are happening is us, because we are actually looking at ourselves to go into the power system. So regular maintenance, as Mr. David has said, Engineer David has said in the chat room, is very, very key. Emergency shut-off system, and then lastly, I said fire safety protocols. When I talk about fire safety protocols, I'm talking about procedures for fire system. So you have installed fire extinguishers in the appropriate places, and you have fire training for your people. You need to make people to be aware of actually the type of work that they are carrying out in their environment. So I'm going to go a bit faster now. We have what we call the hydropower plants. I think this is the most common in Nigeria. The hydropower plant uses energy of falling or flowing water to generate electricity. And that is one of the things, I think, one of this that is actually in. So I think after that turbine boiler explosion, Pura Falls decided to use hydro. They decided to use, they switched to hydro. So, and it is just the waterfall that is flowing from dams, from rivers to generate electricity. So they are renewable energy source, utilizing water from rivers, from dams, and some from reservoirs. What are also the components? The reason why I'm mentioning components of this power generation is because if you don't know what you are dealing with, for you to even identify the hazard that is associated with it becomes very difficult. So you need to know the components, and then you are able to identify the hazard that are associated with this, and then you look for ways to implement or mitigate accidents. So we have components that are associated with hydropower. We have the dam, we have the penstock, we have the turbine, we have the generator, and we have the spillway. When we talk about dam, we are talking about where water are stores and controls for flow. Then when we talk about penstock, it is a direct water flow to the turbine, sorry. The direct water flow, the direct flow of water to the turbine. Why we have turbine, I think I've mentioned that, is the water flow drives. So when the water flow, and you know, the process of the water flow is actually being reduced. You may have a large, how will I put it? You may have a large pipe that will now be converted, maybe let's say 10 mm pipe, now convert, okay, 50 mm pipe, converted to 40 mm, converted to 30 mm, converted to 20 mm, converted to 10 mm diameter. And those pipes, you know, as their diameters are being reduced, they are going out with a great force. So those force will end up turning the turbine, and the turbine are going to convert the rotation that takes place in the generator, which now converts the mechanical energy from the turbine into electrical energy. So we have the spillways. I took my time to actually tell you this so that you will know that there is also pressure that is associated with this particular component. So we have the spillway. This is just maybe when your dam is full, you have a lot of water, it's just for you to release it so that it can go. You release it. It's depending on the way you control your flow of water. So it's just releasing the excess water to prevent dam overflow. And these are also things that can actually pose hazard to the power generating system. What are now the the hazard and the safety measures that can be put in place in these components? You see, the hazard that are associated with hydropower plant, one is flooding. Because sometimes when you release your spillway and it goes into the community, there is a place I know. Okay, let me give an example, Shiroro. I have also gone to Shiroro for an excursion. And one thing I discovered is that once the dam is full and they are going to open for spillway, they inform the community ahead of time. They start their announcement maybe in 2 weeks or in 3 weeks. They inform them there is going to be a release of this, of that, so that they will be aware and they will take note of some of the activities that they will be carrying out in such places. So what they do is that they pass announcement. So hazards that are associated with this is flooding, structural failure, drowning, and electrical hazard. You see, in all this, electrical hazard is also key. Why? Because you are generating electricity, and what you are generating has also the potential of causing you injuries and even fatalities. What are the safety measures that I need to put in place The safety measures that you need to put in place, regular inspection. You know, in the thermal I talked about, the first thing I mentioned was regular maintenance, but this one, regular inspection, because you need to regularly inspect your dam. You need to regularly inspect your pipes. You need to regularly inspect your equipment. Regular inspection and maintenance. These cannot be overemphasized. Then we also have emergency evacuation plan. Some people die or some people gave up because there was no proper emergency evacuation plan in the generating plant. When incidents happen. So it is when incident happen that we begin to think of what are we going to do? What are we supposed to do? Then safety measures, again, that you need to put in place is the flood control measure. Flood control measure. What are the measures that you need to put in place? Now, I gave an example of the Shiroro Dam is it Kogi or Niger? In Niger State. Is it Niger now? Or Kogi? I think, is it a Kogi or Niger? I forgot. Okay, it's Niger State, Shiroro Dam. So when they want to open these things, the reason why they inform the community is because there is possibility of flooding. So why they inform them is to create awareness. And most times before they do that, they have given them regular community awareness. The use of nozzle effect to booster the pressure. Yes. You see, when you are reducing the sizes and the diameter of these pipes, you are actually narrowing it to become a nozzle because it comes out with pressure. Shiroro Dam is in Niger State. Thank you very much. I get that. So you have to have flood control measure. Then you need to have safety barriers and safety signages. You need to have them in order to prevent some of these barriers. So let me give an instance. Let's assume that you have an equipment. The thing you need to do, some of these machine guards that you see, they are actually safety barriers. Now, it prevents you from what can lead to accident. You remember I told you where I did my sideways, that because of the regular maintenance that is being carried out on the equipment, they removed the machine guard, which actually is the safety barrier, which will have prevented me from putting my hand into the equipment, into the guillotine machine. So now I think I'm going to talk about the nuclear power plants. The nuclear power plants is being generated using nuclear reactions, as the name implies. So typically through fission of uranium or plutonium, some chemicals like that, nuclear chemicals that are used to actually generate electricity. And to interest you, the more reason why, let me even ask this question. Do you think as a nation, we are capable to handle nuclear power plants? I'm waiting for your reactions in the chat room. As a nation, do you think we can handle or manage nuclear power plants? I'm waiting for your reaction. Okay, no, sir. No. Okay, so these plants produce a significant amount of energy from small amounts of fuel. That's one interesting thing about it. Small amounts of fuel. You know, let me give an instance for those of us that have seen a cupboard. I remember back then, we get a small cupboard. We put it inside water, and we cover it with a can. And the next thing you hear is, boom! Now, it might be a little quantity of that thing that must have caused that explosion. So what I'm trying to say in essence is that these plants produce a significant amount of energy from small amounts of fuel. What are the components of nuclear power plants? We have the reactor. We have the reactor, yes. It is called, I think, the reactor core. Yes, the reactor core. We have the control. We have the steam generator, we have the turbine, we have the generator, we have the cooling system. The cooling system can also be referred to either the condenser or, as we call it in the thermal power plants. When we talk about the reactor code, it contains fuel rod where fission occurs. That is where the fission occurs. Then we have the control rod. This regulates the fission reaction. The duty of this fission rod is to regulate the fission reaction. While the steam generator uses heat from the reactor to produce steam. And that is what in turn drives the turbine. And the turbine now converts the turbine now rotates the generator, and the generator, which is a mechanical energy from the turbine, now it converts the turbine into electrical energy. Converts the mechanical energy from the turbine into electrical energy. And lastly, we talk about one of the components is the cooling system. And you know what the cooling system does is to remove the excess heat so that you can maintain safe reactor temperatures. Because if they are being operated in a high temperature reactor, definitely the efficiency is going to reduce. Now, what are the hazards that are actually associated with nuclear power plants? Number one is radiation exposure. You'll be exposed to radiation. And this in turn could lead to skin cancer and other stuff like that. Then we have reactor meltdown. We have radioactive waste. We have thermal pollution. So these are some of the hazards that are associated with nuclear power plants. And then the safety measures that you can put in place, this is strictly safety protocols. Safety protocols that will reduce radiation. You can put on your PPE that will make you not to have direct contact with radiation because it will shield you from radiation. Then regular safety drills. Safety drills cannot be overemphasized in the power generating system, in the power generating plants. Secure containment structure and have a proper waste management. Now, I split some of these safety measures because they also apply to some of these, to all the power plants that we are, the type of power plants that we are discussing. Now, when we talk about renewable energy, which we are going to have the people managing stroke using it are special. Yes, we have skilled people. It is not an ordinary person that we actually handle nuclear, what's it called? Nuclear power plants, definitely. So even the thermal power plant, it is people that are skilled. The hydro power plant, it is people that are skilled. The renewable too, which is a renewable energy, it is the people that are skilled. And I think this particular cohort of the power system training, we're going to be talking about, we're going to be doing the renewable energy, which is one of the interesting part of this training. Because the renewable energy, we will have your solar, you have your, there are different types of renewable energy anyways. We have your solar. Can you mention some of them in the chat room? Let me be watching the chat. Okay, I should mention some of the hazards associated with the nuclear again. Okay, so I said some of the hazards that are actually associated with nuclear includes thermal pollution. Yes, I mentioned thermal pollution. We talked about meltdown radioactive waste. You know, we used to have radioactive waste that comes from the nuclear. So we have reactor meltdown. Then we have radioactive waste. Then we have radiation exposure. These are risks that are associated with this. And I say the safety measures with this is strictly safety protocols. Get gadgets or equipment that are PPEs that are going to prevent you from having direct radiation impact on your body. Then regular safety drills. Then you secure containment structures. Then we talk about waste management. Thank you very much. Under the renewable energy. We have the hydro, okay. Hydro, yes. We have the wind, solar. We have the wind energy. We have the solar energy, renewable wind, solar. Thank you very much. And biomass, beautiful. Biomass energy, beautiful. But I am just going to talk about few of them, and then we are going to forge ahead. So under the renewable energy plant, we have the solar. Solar uses the photovoltaic, is it voltaic now or voltaic? Yes, it uses the photovoltaic cells to convert sunlight directly into electricity. What are the components of solar energy? Wow, I think I'm hearing this one for the first time. Tidal energy. Okay, thank you very much, Wasiu. Photovoltaic. So what are the components of solar energy? What are the components of solar energy? I want somebody to mention that. I'm looking at the chart room. Okay, we have the solar panel. Excellent. Thank you very much. I just want to be sure that we are together. We have the charger controller, we have the inverter, we have charger controller. Thank you very much, Emmanuel. Thank you, Livinus. Thank you, Wasiu. Thank you, Lola. So beautiful. We have just given the component of solar inverter, solar energy, sorry. So we have solar panels, we have the inverters, we have the batteries, we have the controllers, we have the PV modules, we have the charger, and so on and so forth. So we're not going to mention all the components, but what are the hazards that are actually associated with this renewable energy? Electrical shock. We have falls during installation. When you go for installation, especially if you're going to install at height, there is a tendency of you fall during installation and even during maintenance. So exposure to also hazardous materials, like those chemicals that we mentioned, photovoltaic, is a combination or is a compound that actually can have a reaction when there is a direct contact with our skin. So these are some of the hazards that are associated with solar energy plants. Then what are the safety measures that you need to put in place? Proper PPE. You need to devise a means of secure installation practice. You need to have a means of carrying out a risk assessment before you do your installation. So you need to devise a methodology. We used to call them method statement of how you are going. So I want you to note this, that the way you carry out installation in, how will I put it, in my house will definitely be different from the way you will carry out installation in engineer Yusuf's house. So in as much as we know that, you should always have different method statement. There is nothing like, I don't do this thing. You know, when these things will happen, they will never inform you. So therefore, it is very, very important that you have a method statement for your installation. Then you have regular inspection, equipment inspection. What are the equipment? Your PPE, you need to inspect them. So when you are inspecting your PPE, you need to know things that you need to check, and so on and so forth. So who can give us some of the components of wind power plants? I'm going to talk briefly on that. Wind power plants. I'm looking at the chat room. Wind power plant. We have the turbine, yes. Turbine, yes, you're correct. Excellent. Okay, because of our time, we have the turbines, we have the blades, we have the tower, we have the reactors, beautiful. We have the generators, we have the blades, beautiful. We have the control system also. So The hazards that are associated with these are mechanical failures. We have falls during installation as well. We have electrical hazard. We have high stroke. So, and this part of the world, we don't have any high stroke, but definitely there are also risks or hazards that are associated with a wind power plant. So what are the safety measures that we need to put in place as well of this is regular maintenance, safe climbing practice, emergency shutdown system, lightning protection. So having said all this, I am very sure that you are familiar with electricity. I remember back then we were being told in my EEC class, they will tell us that electricity is your friend. In as much as this particular thing is important and is essential for our daily living, it is of important for us to note that we need to actually know how to relate with these things, especially electricity. The big question is, despite the fact that we have witnessed people being electrocuted, we have witnessed the disaster of electrocution, we have witnessed the disaster of electric shock, why do we still have high rate of electricity, shock, and electrocution in our society today? This answer is not far-fetched. We are hurt and killed because in a commonplace world of our society today, and even in our homes, it is surprisingly easy to forget how dangerous electricity can be, in as much as it is one necessity that we need either for industrialization or for our homes. Make safety your priority. So talking about power generation, you all know that there are some terminologies and some things that actually could affect us. And that is, I think I have mentioned some of them in the previous slide that I did talk about. I said the high temperature, I talked about electrical hazard, I talked about chemical exposure, I talked about mechanical hazard, I talked about fire and explosion risks. Okay, I didn't talk about noise hazard. And I think this is very, very important. So I want somebody to go help me find out what is the maximum level of sound that our ear is expected to have in LBS. What is the maximum level? If you know, you can also drop it in the chat room. What is the maximum level of sound that our ears are supposed or expected to have? $85 dB, okay, 85 dB, 85 dB. Thank you very much. So we have 85 dB. So definitely, if you find yourself, you know, if you have visited the power generation plant before, there's what we call earplug or earmuff. For those of us that will be visiting Egbin power plant, I advise every one of you to make effort to visit this place, because you're going to see a lot of things and you're going to be exposed. So, but there are some basic things which I know we have been told to get together. Get your hard hat, because even if you get to Egbin, there's possibility Egbin will give you hard hats, and they're going to give you, I'm not sure of reflective, but they're going to give you hard hats, and they're going to give you earplugs. However, it is important also for you to have your own, so that even if you're not giving, you have your own in place, and you can use your own in order for you to protect yourself, because it is called a personal protective equipment. So power plants generate high level of noise. It is very noisy. Now, you can imagine you listening to more than 85 dB every day. You're listening to more than 85 dB every day. In fact, when you go back home and you want to sleep, your ear will be configured in such a way that the sound will actually be telling you, it will be making that sound. So, and that's why some people, you discover that over time, because they are used to the sound, whenever you want to communicate to them, you have to shout. The reason why you have to shout is that their ears have been configured into that sound and they don't hear you. That sound has overshadowed their earbud. And so therefore, for you to say something to them, you have to either shout it in their ears or you shout it from a distance before they can hear you very well. So hearing loss is due to the prolonged exposure to high noise level. And it creates difficulty in hearing even alarm when there is an alarm that is being raised in your place of work. It's very difficult also for you to follow instructions because you didn't hear. So the best thing to do is use hearing protection like earplugs or earmuffs. Implement noise control. I remember I worked in one of the facility in Ikeja, one of the beverages facility in Ikeja. And when I got to the place newly, I noticed that people, some of their plants were actually noisy. And to be sincere, these people do not use earmuff. They said it doesn't make them comfortable. Now, I make them see reasons why they need these things. It's not that you are, see, safety gadgets are not meant to make you comfortable, but they are meant to protect you. So you need these things in order to protect yourself. So what I'm trying to bring out from the story was that we got a device that is actually used to measure the noise level of the environment. And I introduced that. And now I can tell you that we now got earplugs and earmuffs, which they use regular to protect the ears of their employee. Then in turns, if you didn't do this thing, it reduced productivity. And you know, a businessman is after what? Results. Then regular, you need to go for hearing tests. This is supposed to be carried out by either your organization or thereabout. Then you need to indicate the noise level of your environment. There's a need for you to do that. And if they don't, ask questions. Okay, what is the noise level of this place? They may tell you they don't know. But for the fact that you have asked, you have put them into, you have given them an ISO that they need to really work on. So what are the safety protocols? The first thing you need to know, the safety protocols and procedures. The first thing you need to know is your hazard identification and risk assessment, which I mentioned earlier. You need to conduct thorough hazard identification and risk assessment to understand the potential dangers in power generation processes. Because you cannot assume, you cannot presume. And I can tell you that I have visited about either I've visited 3 power generation plants in Nigeria. I mentioned that of Shiruru, I've mentioned Egbe, I've mentioned that of Kura Falls. That's, yes, Kura Falls. That's a private one anyway. And the process, the safety process of safety protocols of Shiruru is different from that of Egbe power plant. So some of these are things that you need to know. You can say that, yes, I ate eba today. If I'm going to eat eba tomorrow, it's still safe. No, the fact that you are doing it the way you are doing it does not mean it is safe. So you need to regularly update your risk assessment to reflect any changes that you notice in your operations or either in your equipment. These are some of the procedures or the protocols that you need to put in place. And there's what we call the HAZOP. This simply means HAZOP, H-A-Z-O-P. This simply means hazard and operability study. Hazard and operational. It's just the mixture of hazard and operation. And we call it HAZOP. Then we have what we call the FMEA. This one is failure modes and effective analysis to identify hazard. You can use that also to identify hazard in power generation and then involve multidisciplinary teams in risk assessment to ensure comprehensive coverage. Now, you cannot do it alone. Don't forget, you cannot do it alone. I think I have given a discussion about the lockout tag out. I'm not going to discuss more on personal protective equipment, lockout tag out. Then we have the safe work practice. When you start work, please, what you don't know, don't presume to know in health and safety. Now, let me give you an instance. You remember I did tell you that, okay, I work in one of the manufacturing of beverages in Nigeria, a very top company. It's a multinational company in Nigeria. I don't want to mention the name. So my manager told me that, okay, we went for a walk around and my manager told me that, go and put up that equipment. Let me see. Let me see what will happen. And I told him, I said, sir, I was not trained to put up an equipment. I'm not skilled in that. He said, it's not just to turn it off. You can see on and off. I said, sir, I don't know what that will do. And me, I was ready for the worst. Because if I put that thing off, I don't know what will happen. So he now called the technician who was actually operating the equipment and told him that, okay, go and put off that thing. Let me see what will happen. Lo and behold, out of fear, the technician went ahead and put it off. It shut down the company for 3 hours. And you know what that means to an organization, a multinational company? You can imagine the amount of money that they must have lost. So it is very important for us to put some of these things in consideration. And I remember that when I came on the day of the opening ceremony, I said that if a switch is put on down in your house and you go to another person's house and you see it down, it doesn't mean it is on. Don't presume. Always take safety serious. It is very, very important. So LOTO is actually the procedure of ensuring that machinery is properly shut down, not start up again. I think I'm still going to say something as regards the logout tagout when we get to, I think I have a slide that talks about that. Then we have emergency, we have safe work practice, do your work safely, carry out that work safely. By implementing safe work practice, you are minimizing risks and ensure a safer work environment. Wow, our time is fast spent. So we have emergency response plan, we have inspection and maintenance, which I've actually mentioned. We have training and competency, just like what we are doing now. And remember, I said that if you have not been trained, do not carry out a task. Then lastly, we have regulatory compliance. Regulatory compliance, this is government or maybe organization policies. When you do this, you are saving your organization from litigation. And that in turn is going to be a bonus to you. Here, I want us to have a short break. Yes, I'm going to round up very soon. We're going to have a short break. And I want us to actually answer this question. If one man can dig one hole in 2 days, how long will it take for 2 men to dig half a hole? So I'm waiting for your answers. If one man can dig one hole in 2 days, how long will it take for 2 men to dig the hole? I'm going to call on anybody to tell us something. If you are on the call and your name, I can just call on you so that I will be sure that you are with us. So I'm waiting for your responses as regards what I just asked. If one man can dig one hole in 2 days, how long will it take for 2 men to dig half a hole? This is a simple mathematics now. I believe we're all engineers here, and we know engineers to be good with mathematics. Okay, Ayodele says half a day. Okay, thank you very much. Do you have anybody else with a contrary response? Actually, 1 day. Okay. Okay, half a day. Ayo. Dele says half a day. Emeka says actually 1 day. Okay. Oko Wilson says half a day. Emmanuel says 1 day. Okay. Karina says half a day. Okay. Gabriel says it depends on the size or depth of the hole to be dug. Okay. Lola says half a day. Okay. I'm going to call on. Okay. Somebody, Wasiu says 12 hours. Okay. I'm going to call on Ayodele to unmute and tell us why you said it is half a day. Then I'm also going to call Lola to also unmute and tell us why it is half a day.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, everyone, the participants. Yes, based on the question says that if one man can dig one hole in 2 days, how long will it take for 2 men to dig half a hole? Yes, from my own, or let me put it this way, with my little experience, yes, we are talking about maybe the division of labor here, that yes, there is a task for a person to do, and that task take that person for 2 days to accomplish it. But in another scenario, we now have 2 people to also do the same task. But this time around, the volume of that task has been reduced, even compared to the one person that has to do that task. And maybe the task also what 1 hole now to do in a day. But the volume of the task now has been reduced to half of what 1 man should do in a day. So if 2 person or 2 people now have to do that task, to me, I believe that it will not take them more than half this. Adibi is also maybe 1 hole, per 1 hole for the 2 people to do, which 1 man accomplish in 2 days. I will say that, it will take the 2 of them 1 day to accomplish it. But the volume of this task now be reduced to half. So,
okay,
to me, I believe that it should
thank
be
you
able.
very much, Ayodele. Lola, are you there? Lola Esther.
Yes, sir, I'm here.
Okay, you can speak.
Good afternoon, everyone.
Good afternoon.
Yeah, concerning the questions you had, I just normal logic, normal physical thing that we can just see that, okay, it takes 1 man to dig a hole for 2 days. So when the capacity, because what I actually use is there that they use the same pressure. If 2 persons use the same pressure, the same energy to dig that same hole, the capacity is going to reduce. The time frame, is going to reduce. So it will not be up to when a person is digging the hole. So since it's just an half hole, if there are two, it will take them 1 day. So since it's an half hole, I just divide the 1 day by 2.
Okay, thank you
That's
very
it.
much.
Thank you, sir.
Thank you very much for your response, and thank you for contributing. This has shown me that we are actually together. Okay, but it may interest you to know that we don't have such a thing like half a hole. There's no such a thing like half a hole. So the answer is there is nothing like half a hole. If I had said that if one man can dig one hole in 2 days, and how long will it take for two men to dig same hole or have the same hole in 2 days? That's when we can give the responses which we are giving as 1 day or 12 hours. But I want us to know that there is no such thing as half a hole. You can actually make your research to find out. And this is actually a brain teaser for us to just know that we are together and then we proceed. So to further our discussion this afternoon is for us to know, okay, I have talked about emergency response plan. So there is a need for us to always have emergency response plans. Let's not wait until incident happen. And this will lead me to power transmission. And remember, I said transmission system plays a, I said it's just, I think when I was defining it, it's just the way I said in simple terms, I said transferring electricity from one point to another. And we say that it cannot be complete if it has not actually, power system cannot be complete if it has not been transferred to the end users. So transmission plays a key role in power generation because it delivers electricity from the power plant, that's the generation, to distribution substation and end users. So this system are actually composed of high voltage lines, substations, and transformers. Power is transmitted over a long distance at high voltage to minimize energy loss. And I think we were told about that in the first day, the reason why energy are actually produced or voltage are produced in a low volt, or our power is generated in a low volt and it is being transmitted at a high voltage. Now, the essence of this transmitting our power in a long distance at a high voltage is to minimize losses of voltages during transportation. And when we talk about substations act as distribution hubs, it's a place where they distribute the electricity, where voltage levels are stepped down to distribution to either residential, commercial, and industrial consumers. So transformers are used to convert, I think I've said that also, to convert voltage levels between transmissions and distribution phases. So safety in transmission system is paramount due to the high voltage involved in transmitting it. So it requires rigorous maintenance, regular inspections, and even adherence to strict safety protocols to prevent accident and to ensure reliability of power supply. Having said that, there are key hazards in transmission, and that is what we have: the high voltage, the falls, the electrocution, the mechanical hazard, the fire explosion, and then the health hazard. So doing this, you should know that there are things that you need to put in place in order for you to prevent some of these hazards. So having said all this, you should know that high voltage transmission line carry high voltage, which is posing a risk of electric shock and arc flash incident. And the safety measure that you need to put in place is regular training on high voltage safety. In fact, you see, aside from this power system training, there is another training separately for high voltage safety. This is strictly for those in the transmission line that we use for them. So I'm just giving you the some preambles that you need to also have. Then you need to also use insulated tools and equipment and adherence to log out, tag out procedures during maintenance or during when carrying out a repair. Then you have also falls, which are mentioned. Walk at height. You walk at height on the towers and structures. It's also a risk. So the safety measure you have with this is the use of the protection equipment such as body harness, guardrails, safety nets, along with regular inspection and equipment, which you need to put into place. Then when we talk about electrocution, when we take it is electric and execution that we merge together. So when you, this has to do with direct contact with live conductors or equipment, and it can result in serious injuries and death. So the safety measures regarding this is actually strictly adherence to logout tagout, because you have no business with the transmission line if there is no maintenance that is going to take place. And if maintenance is going to be taking place, there must be a LUTO procedure, logout tagout, that must take place. Then you have your PPE and regular electrical safety training. This cannot be overemphasized, and that is why it is important for us, before we go to the field, before we go out, we have our safety training as a branch to beat. Then we have mechanical hazard, which are also, this has to do with also moving parts, such as the winches, the pulleys. These ones too, they pose risks to us. And what we need to do, I think I've mentioned that too earlier, is the machine guard, safe work procedures, and proper training of equipment and operation. Then the fire, explosion, which I also mentioned in thermal and boiler. So that we have, there are some facilities that have fire detection, and they have fire detection and suppression system. I don't know if they may have, but proper storage and handling of flammable materials also are also important when it comes to health and safety. And then lastly, we have health hazard. You see, you can actually be exposed to a lot of health hazard when it comes to power transmission. Exposure to hazardous substances such as chemical that used for maintenance or for construction in the process. There's possibility that you'll be exposed, and that has a great way of, and you know also the radiation of electricity too can cause, and that is why you discover that on the transmission line, it is given by law that there is a certain distance. I want somebody to mention that distance to me. Okay, transformer, transform, not convert. Thank you very much. So I want somebody to tell me, what is the distance that is expected that you should have from the transmission line while I am talking about the health hazard? So now I'm waiting for us in the chat. What is the distance that is expected to have in transmission line that we see on the towers? So having said that, I think somebody's mic is mute. Are you delay? Yes. So having said all that, you need to know that your health is poised to also an hazard. So the use of appropriate personal equipment and training on chemical safety and monitoring of exposure level is also important. So, and these are some of the things that we should know, or the hazard that are associated with transmission line. I'm still waiting for us. Okay, 15 meters away from the transmission line. This will help us to actually know the distance we are expected to. Okay, thank you. For 132 kV, which have 15 meters, while for 320 kV is 25-meter distance. The reason for this distance is for safety reasons, because when there is an issue that needs to be addressed, or maybe there's an hazard, or maybe an incident that happened, you never can tell. All these things have a lot of dangers that is posed towards us. So, and sometimes you use to, I don't know if it's possible or necessary for you to have a safety net under lines. However, it is important for you to note that you must follow the protocols, the rules, the guidance that have been given for you to stay away from transmission line. Then the safe work practice in transmission line is, the first thing is job safety analysis. We call them the JSA, and then risk assessment. It is very, very important. Conduct job safety analysis. The reason for this is for you to identify potential hazards that are associated with a specific task. You need to perform risk assessment. This is for you to evaluate the severity and the likelihood of this hazard. If you do this, you're going to help yourself and you're going to help your organization, because it involves there are things that if you don't do them, they will do you. If you don't do them, they will do you. So electricity is a major hazard in transmission. It's part of what I mentioned, electrical safety. Electricity is a major hazard in transmission system due to high voltage. And implementing logout, tagout, I can't overemphasize this, but there are things that you need to know: the fall protection, confined space entry, personal equipment, hazard communication. I think let me talk about the hazard communication. There should be an effective communication of hazard. Very, very important. You must go. There's this slogan that we used to have with my colleagues: see something, say something. The hazard you did not report today will come back tomorrow and it's going to haunt you. So effective communication of hazard is crucial to ensure workers are aware of risks and proper precautions are taken. So, and how do you do that? Use labels, use safety signages, use verbal communication, we call something induction. By the time you go to Egni, induction will be carried out. By the time we went to Shiruru, they did induction for us. So these are some of the things that you need. Okay, this place that you are coming, these are the hazards that are associated with this. This is what is expected for you to do. So you use labels, safety signages, verbal communication to actually identify hazard and even chemical hazard, and then you communicate them. Then you provide safety data sheets for hazardous materials. Now, if you look at most chemicals, they used to have their safety data sheet. And what they do is that they tell you the risks or the hazard associated with this chemical. They tell you the risks, and then they tell you some of the safety measures that you need to take in order for you to correct it when accidents happen. So, and then lastly, we have equipment and tool safety. So this is proper use and maintenance of equipment and tools are essential to prevent accident and ensure operational efficiency. Having said all that, look at your screen. Captain Ali is the captain of the ship. The captain of the ship is Ali, or the captain of the ship is Captain Ali. What is the name of the ship? What is the name of the ship? I'm looking at the chat room. I want you to respond. Let me read the question again. It says Captain Ali is the captain of the ship. The captain of the ship is Captain Ali. What is the name of the ship? Are we together or I am alone?
We are together, sir.
All right, thank you very much. All right, I'm waiting for your responses. Okay, thank you. Okay. UASC is the name of the ship. We are together. I'm gonna say UACS. UASC. Okay. Okay. Interesting. So I'm going to call on the first person, Mariam Titilayo. Unmute and tell us why you said UASC is the name of the ship. And I'm going to call on Ibrahim, who have a contrary view, who said Captain Ali's ship, to unmute.
Yeah.
All right, thank you. Good afternoon, Mariam.
UASC is indicated at the surface of the ship, at the external parts of it. Is indicated there, sir.
Okay, thank you very much. Ibrahim.
Yeah,
Okay, Lola said it's not given. So Ibrahim, can you unmute and speak and tell us why you said Captain Ali's ship?
That was the content we were given. The question, the statement we were given, Captain Ali is the captain of the ship. Then the captain of the ship is Captain Ali. So they're talking about Captain Ali's ship. The specific name of the ship wasn't given, so we can only assume it's Captain Ali's ship.
Thank you very much for your responses. But it is interesting for you all to know that the name of the ship is what? Let me use my pen so that you can see. Okay, confirm if you can see my pen. Can you see it on your screen?
No.
Okay. Oh.
Yes, sir. Blue.
Yes. Okay. So do you see what? What is the name of the ship? The reason why what is the name of the ship is because, sorry, I'm trying to pick my tool back. Oh, okay, go back to this. Okay. Okay. Close. Then let me get my eraser to clean this. Let me clean this too. Okay. So the question, there is no question here. Do you agree with me? If you look carefully at the third sentence of the riddle, what is the name of the ship? It's not written as a question and is a sentence that is literally telling you the name of the ship, even though there is no question mark. People still perceive that it is a question and never realize that it is actually the answer to the riddle on the screen. So thank you very much. This one say, I can see it. Yes, there's no question. Honestly, there's no question. Truth. Yes, there's no question here. Now, the reason for this is for you to pay more close attention. Don't assume. You see, in safety, we don't assume. And you will agree with me, as engineers, we don't assume. So you use even the fact that no full stop, yes, is a sentence. It may be a continuous sentence. It may not be a continuous sentence. So what is the name of a ship? And there is no question mark. So, but because the way it sounded, a lot of us have it in our head, and we concluded that it is a question. This is more reason why we need to pay more attention. This riddle is actually is great for testing your observation skills. And as engineers, we need to be observant. Moreover, it is also testing your grammatical knowledge and awareness. And that is why it is important for us to have effective communication. So with this, I want us to pay more and close attention to whatever we do. If you go to the site, please pay attention to the site and pay attention. Oh, Gabriel said this is quite interesting. Thank you very much, Gabriel. So there's no question, but you pay attention to details. Now let me talk about risk hazard. I have been mentioning risk hazard over the time, incident and accident. So let me just quickly say this. It is a risk. I think I've said it shortly. But before I go into that, I think let's just stretch our legs for just 2 minutes. Let's stretch our leg for 2 minutes. I'm doing that on my own. Did I say 2 minutes? Let's just stretch our hand. The answer is what? The answer is what? The answer is what? What is the name of the ship? That's the answer. Wasiu. The answer is what? And the reason why I said it is what is because it's not a question, it's a statement. What is the name of the ship? What is the name of the ship? So it's not a question. So are we back? Are we back together? Let me be sure. Drop your message, drop your best emoji in the chat room. Let me see. Don't worry, we are rounding up. I don't intend to take much of our time. Thank you, John Ude. Detailed and effective communication is the backbone of engineering. Thank you. The answer is what? Because the last sentence is not a question, but a statement. Thank you very much. Good luck. Okay, are we back? Okay, this shows that we are back. Thank you very much. Emeka Akulu. Yeah, sorry for that emoji, yeah? All right, risks. Risk is actually the probability or the likelihood of an adverse event or occurrence and the severity of the consequences of that event. So in safety terms, it involves assessing the potential harm and determine the necessary controls that we will need in order for us to mitigate these risks. So an example is electrical shock while working on a live electrical equipment. That's a risk. That's an example of a risk. Then when we talk about hazard, I have said that several times, it is anything that has either the potential to cause you harm or this. Now, some of these hazards could be physical, it could be chemical, it could be biological, it could be ergonomics, it could be psychological, it could be mental. Those are some of them. That's what they can cause. So an example is exposed live wires in electrical system is an hazard. An exposed live wire system. If I have a wire system like this and it has a break around it, it is exposed. That is an hazard because it has the potential of causing injury. Then we have what we call unsafe act. Unsafe act is any action that actually deviates from the accepted safety procedure. Maybe you are supposed to use your ladder to climb onto a particular place and you did not use your ladder, you decided to use the tables. This is an unsafe act. It is an unsafe practice. So, and because of that, we call it unsafe act. You are bypassing safety protocols on machineries to speed up your work. You are bypassing safety measures in order for you to finish your work on time or to meet target. That is very, very wrong. So, and that is what we refer to as unsafe act. Then when we talk about unsafe condition, many people used to have a misinterpretation or confused with this particular one, which is unsafe condition. So when we talk about unsafe condition, it is a physical state or environment that is likely to cause injury or damage. Now, remember, unsafe act has to do with you, while unsafe condition, it has to do with you, the environment, or the equipment. Now, when the weather, let's assume, is cloudy and you're driving, it is an unsafe condition. So you driving, okay, it's raining heavily. That is unsafe condition. You now driving inside the rain is unsafe act. Because you know definitely you will not be seeing a distance inside your car. So you driving inside the rain is unsafe act, and then the rain already is unsafe condition. So for example, again, you're working in power transmission, either distribution, and you have a cable that is actually broken. The insulators are off it. That is an unsafe condition. So you now working in that environment poised you to be at risk, and that makes you to be acting unsafely. That makes the situation to be unsafe act. And I'm sure you are to getting that clear. So an example of actually unsafe condition is slippery floor. Let me give an instance of that. Slippery floor in the power plant due to oil leaks. Maybe when there is a leak of the oil on the floor, that's unsafe condition. You now coming to walk around that place is unsafe act. Then we have incidents. There is a lot of confusion between incidents and accidents that people used to have. So when we talk about incident, it is an event that actually, it is an event that results in unintended harm or damage, or has the potential to cause harm or damage. It includes maybe near miss, where no injury or damage occur. Another way you can actually talk about this also is the fact that incident is an occurrence. It could be, it must have led to accident. It might not have led to accident. So, and that is what we refer to as incident. So an example of that is a technician dropping a tool from a height and narrowly missing another work below. So for example, let's assume, I want to use a name, Good Luck is working at height and it dropped a spanner from that height down, and the thing nearly hits Emmanuel Temitokwe, and Temitokwe down, the thing did not hit him. That could be recorded as an incident. It's not an accident, but it's an incident. An accident can also be called an incident. Why? Because it has occurred. So the reason why there is a difference between incident and accident is because accident, it has happened. But incident, it's possible it has happened and it causes an injury. It's possible it did not happen. So it's possible that Good Luck threw the spanner from height and it fell on Emmanuel Temitokwe, and Emmanuel Temitokwe was injured. That's an incident. Now, it is possible that the spanner was dropped on the floor and it did not hit Temitokwe, but nearly hits him. And when it nearly hits him, we call that a near miss. So when you see a near miss, please report it, and that will help you to stay away from incidents. So quickly, I'm going to talk about inspection and maintenance safety. So it is very, very key for you to carry out inspection and maintenance. These practices are crucial for ensuring safe operation of transmission system regularly. Inspection of equipment, infrastructures, this seriously is very, very important. And detailed inspection checklists should be developed. There should be a checklist that you will use in order for you to use to inspect your equipment. And this cannot be done by any type of person. Detailed inspection checklist. This should be developed for all equipment, including power lines, transformers, substations, and so on and so forth. And it's not any kind of person that can actually do this. They should be qualified personnel. And new question, sir. Can incident be referred to as unsafe act or condition? Okay, now when we talk about incident, it's an unsafe act. It's due either to, because one thing you need to know is that some things that, okay, unsafe act is things that happen deliberate. Did you get me? Unsafe act, there are things that you actually do deliberate, things that you do by yourself. But when we talk about unsafe condition, we are talking about some things that are not really deliberate. It's not what you use. It's not you that caused it. The thing has been there. But you now coming to do that is what leads to that incident. So when we talk about incident, we are talking about something that is actually not planned. You know, I'm looking for a better way to put this. An event that results in unintended harm or injury. And that is what leads to near miss. So either if you are categorizing this, if you want to categorize incident under unsafe act on unsafe condition is dependent. The cable that is broken is actually an unsafe condition. And you know, definitely that can cause or that can lead to incident. So anything that happened under incident, we don't categorize it under unsafe act or unsafe condition. We categorize that under near miss. So when it happens, it becomes an accident. But when it did not happen, it becomes a near miss. So you cannot take incident to go to either unsafe act or unsafe condition. What I am doing becomes unsafe. That is where you call it unsafe act. And I give an example. You climbing the wall with a stack of tables is an unsafe act. So unsafe condition is when there is a broken cable and you allow electricity to be flowing through it. That's an unsafe condition. So when we talk about incident, it is an occurrence. It has happened. But did it cause injury? No. Did it cause damage? No. But did it happen? Yes. That is a near miss. So when it now happened, that is when we call it accident. So you cannot put, okay, thank you very much. Incident is an unsafe act. No, incident cannot be, yes, it's an unsafe act. It's an unsafe act, but most times you can actually define whether they are deliberate or not deliberate. I hope I have responded to your question and that is clear. So now let's talk about power distribution, and this will bring me to actually the last part of this, our session. I know if I had come physically, we would have spent more time. I'm sure that this class has been interactive. I have tried to be as interactive as possible, and I've tried to use the little terminologies I can use as much as I can. So when we talk about distribution, this is a network system, and it's a crucial part also of the power grid that delivers electricity from transmission substations to consumers. So here, you will agree with me that we have different components, just as we have actually discussed in other section of both generation and transmission. So in distribution, we have different components, which we have the transformers, we have the switch gears, we have the circuit breaker, we have the bus bar, and we have the conductors. There are many. The transformer either step down or voltage levels from transmission to distribution. So that's what it does. It steps down voltage from the levels of transmission to distribution level. Then when we talk about the switch gears, it actually controls and protects the electrical equipment in the substation. Circuit breaker provide overcurrent protection and can disconnect circuits during fault. And the bus bar, I think some of this has been discussed either in our classes or not, but you have a first-hand information. But I'm very sure that we are going to still talk more on it. Then distribute electricity within the substation. That is what the bus bar conductor does. So having said all this, there are different types of distribution transformers, and I'm sure we are going to be talking about that in our class. Then we need to also understand that we need to protect our devices, and that is why it is important for us to do grounding. The components of this, we also have fuse that is used to protect against overcurrent by melting or breaking the circuit. So grounding equipment is also important. Save direct electrical force to the ground and protect either your devices or even people around them. We also have surge arresters. I visited an oil company recently and I discovered that there are different types of arresters that we have. This also protects against voltage surge caused by lightning or even switching off and on or changing over of operations. So these are also things that we need to put in consideration. So having said that, we can, during in distribution network, we post several hazards as I have done for other ones. So that must be, we have hazard that actually must be managed to ensure that safety of personnel and reliability of electricity supply are actually put into consideration. So we need to know that. Then what are the safety measures that we need to put in place? You need to implement strictly log out, tag out procedure. This is to de-energize circuit before maintenance. You need to use insulated tools and personal protective equipment to actually protect and prevent yourself from some of these things. Then maintain safe distance from live conductors and overhead lines. This will also help you to stay away from this. Now, I want to ask a question before I conclude. If you are carrying out a maintenance on a particular equipment and you need to carry out a log out, tag out. So let's assume you want to work in the switch yard, and because you want to go inside and you discover that it is locked. So, okay, no, you are inside and you want to work on a particular line, and you enter the switch yard and you saw that somebody is already working on it, but the place where you want to go and carry out your work is different from where that person is working. Then what will you do in that scenario? I want you to put up your hand and answer the question. Let's assume you are going to carry out a task on a line, and you went to this and de-energize the line, and someone is actually working on that same line, and the person did log out, tag out. And you are also going to go and do another task on that line, and you get to that place because you want to do log out, tag out, and you discover that somebody has done that. What are you going to do?
I will double tag.
You double.
I will double tag.
Thank you very much. Who is that?
Wasiu Adewumi.
Wasiu Adewumi. Thank you very much. You will double tag, so that when the person finishes work and come and remove his own tag, your own tag will be there. The person will have an idea that you are also carrying out a task on that line. Then we have safety measures for technicians in distribution stations. And what are the safety measures? Insulated gloves that you need to put on to protect electric shock. We have safety glasses to protect your eyes from debris. Then you have hard hat to protect your head from falling objects. You have flame resistance clothing. This one is important. You have high visibility clothing. This ensures visibility in low lighting places. And most of them have procedures, and that will help us. So this is the purpose of, we have a log out, tag out procedures. As the purpose of log out, tag out procedure, I think I've explained that. Then we have steps in LOTO procedures. There is a step that you need to carry out your log out, tag out. Preparation, shutdown, isolation, verification, application of log out, tag out device, release of stored energy. These are process of your log out, tag out. I'm going to come again. Okay, you also perform your own LOTO and take your own keys. Yes, you use your own LOTO. Yes, and take your own keys. Your life is in your hand. So it's either you drop the key or you take it along with you, but it is advisable that you go with your key. Now, I talk about LOTO procedure. LOTO procedure involves specific steps that you put. Now, there are actually peculiarities with these things I'm saying. There are peculiarities with your procedures of log out, tag out. But the basic ones that you know, or the generic that you should know, one is preparation. You need to notify affected personnel about the planned maintenance or repair that will be carried out. So you identify all energy source and types, including electrical, mechanical, and pneumatic, and even gravitational. Okay, Emeka, you can go ahead and ask your question.
Thank you, sir. So he said if someone is working on a line,
yeah,
and he has already indicated the LOTO, Okay,
Yeah.
so for example, this lockout, tag out we are having on this screen, how is it possible that you yourself, you want to apply your own lotto here? How is it possible?
Okay, now, beautiful question. If you look at, we have different types of log out, tag out. We have different types of log out, tag out. Now, this particular one that I use, if you look at it very well, you will discover that there are different holes on it. I think from what I am seeing on this particular one, you can see that there are about 4 points where you can log out, tag out. So when you want to carry out a log out, tag out on this type of equipment, and you need to come and carry out your own, look for another hole and tag your own. Because this person, when he finish, he will come and remove his own log out, tag out and go with it. If there are 3 people that wants to work on the line, you can see there are about 4. So before it gets to that 4, you will discover that maybe one person will have been done with his work. And in the situation whereby one person has not been done with his work and all these 4 log out, tag out position has been tagged out or they have been logged out, what you need to do is to hold on with your own log out, tag out. You hold on with your own exercise until there is a space for you to tag your own work so that you can lock it out. Because if you assume that, okay, all this space have been occupied, all this space has been exhausted. So because of that, let me just go and carry out my work. I can tell you in less than 5 minutes, the 4 people that actually tag this equipment can come and untag it. So when they come to untag it, definitely you can tell what will happen while you are still working on your own line of distribution of electricity. Thank you very much for your question. I hope I answered your question. If I have not, you can also let me know in the chat room and then we'll do justice to it before we leave because we're actually rounding up. So I remember I said we have, okay, somebody asked do we have the acronym called LOTOTO? Yes, I wouldn't say for now if we have anything called LOTOTO, but I know we have something called LOTO, and the LOTO is log out, tag out. So I don't know if we have log out, tag out, tag out. But it is possible that we have those acronyms. It's depending on the way you put it, or it's depending on your explanation. Remember, I said there is no wrong answer and there is no right answer. This is because everybody has a perspective of what he or she thinks. And that is why when you see 6 or 9 written on the floor, to somebody it may be 9, to another person it may be 6. So it's possible we have LOTOTO, it's possible, but I can't really say for now. So remember I said we have procedures for LOTO. The first thing is to prepare. And after preparation, you shut down the equipment and the machineries using the normal operating controls. And you ensure all stored energy, such as the capacitors or the springs, are safely released so that there won't be energy on the line. So having done that, you do what we call isolation. By doing isolation, you are disconnecting or isolating the equipment or the machinery from its source of energy. Then you use log out device, e.g. your logs, your chain, or your valves. This is to secure isolation point. Then the next step is verification. Test the equipment or the machinery to verify if it has fully or it's really de-energized. Then you ensure no residual energy. When we talk of residual energy, we are talking of some tiny energy that are actually stored in your device. This could cause, how will I put it? This could cause a serious disability or fatality in the industry. I will come back to you, John, but let me conclude with this. So application of log out, tag out device, also apply log out, tag out device to energy isolation points to prevent re-energization. So application of log out, tag out devices and tags. This will help you to avoid re-energizing so that somebody will not come and energize the equipment. And if you think that you are not going to tag it, you just lock it. Somebody will just come and maybe if the key is available, the person will unlock it, untag it, and then continue with the work. So you use tags and you lock it. Then the last one is release of stored energy. Relieve any residual or stored energy to prevent unexpected movement or startup. By this, you are applying appropriate methods to release stored energy that is safely saved. This has really given you the breakdown of the procedure. Don't forget, I said there are some peculiarities that actually you can embrace in your facility. So, John, I think you want to ask a question. You raised up your hand. Certainly,
yes, good afternoon.
You're going to get the
Good afternoon, one and
yeah, good afternoon,
can
John.
you hear?
Yes.
Yes. So I was about talking about the Lotto talk. I think in the course of your explanation, you've been able to touch it. You know, when you have Lotto, I think you need to check and confirm, cross-check if the actual power you are taking out, you are trying to Lotto has already gone, has really been done. So by checking, either if you are, let's say you are putting off a breaker from a panel, you are now checking using your multimeter to check if actually that power you put off has really gone out, using your meter to check. That is the try out. The try out, you check it very well.
Okay.
If what you have actually performed really worked.
All right. Thank you
before
very
you
much.
start your job. Yeah.
Thank you very much for your insight as regards that. So what he's saying is that the LOTOTO, the acronym LOTOTO, is for you to log out, tag out, and test out, right? Okay. If that's what it is, they are also part of what we have in terms of procedures that are actually needed. Then remember, under your logout tagout procedure, we have the training responsibility, we have documentation and record keeping. Then lastly, we have compliance with standard. This particular one you need to know: community and public safety in distribution networks. Don't say because you are working in generation, you are working in distribution, nothing concerns you with your public. In health and safety, we always tell people community engagement is very important. And if you do not engage your community, in fact, you yourself, you'll be out of business because they will not give you rest until you actually carry them along. So ensuring community and public safety is essential when you are operating and maintaining distribution networks, whether generating, transmission, or distribution. Why? Because this key consideration is a very key safety measure. They are going to, imagine when I was talking about Shiroro, if there is no communication, if they didn't consider the community and they decide to release the spillway, they decide to open the spillway because the dam is filled, it's going to cause a lot of havoc in the community. And you know, when they get angry, the community get angry, they are going to come to your station. They're going to come to your, I have seen several times where power restore high voltage and almost everything is got burnt. People team up and go to NEPA office. I'm sorry to use that name. They go to some of these disco distributors. They go to disco's office. Come, why are you people giving us power supply that is burning all our equipment, all our gadgets? Now, things like that, you can meet with people that are aggressive. So while you are doing whatever you are doing, always make sure that you put this in consideration. Then we have emergency response plan. We have hazard identification and mitigation, which we have also talked about. Communication and education. This actually goes in line with training. You communicate, effective communication, and you educate the community, raise awareness and promote safety within the community. Why? Because even if you are generating electricity, you can imagine somebody coming to build a house close to you. If there is a safety communication, there's safety awareness that has been raised, definitely they will know that, come, in this community, at this social place, I'm not supposed to raise a structure. So you communicate safety information through the public awareness campaign, radios, or maybe through their community, town criers, the kings, the chiefs. You use that to actually do that. You provide educational materials about electrical safety and hazards to schools, communities, and organizations, and to the general public. As you are doing this, you may think that we are wasting money, but you are actually empowering yourself, and in turn, they are not going to disrupt your work. Then when we talk about environmental protection, protecting your environment from potential hazard is associated with distribution networks, and it is essential because ensure you need to do this. The safety measures that needs to be in place is that ensure compliance with environmental regulations and guidelines for construction, maintenance, and operations. So when you are implementing this, it's going to help. You need to also implement spill prevention, prevent spill, and response measure for hazardous materials by the time it occurs or by the time it happens. You need to also promote sustainable practice and minimize the impact of distribution networks activities on the environment. If you are doing so, I am telling you, you will stand out in all that you do. Then collaboration with stakeholders. You need to collaborate with stakeholders to foster the safety environment. I think I've mentioned that. I mentioned the community heads, the chiefs, the obas, the ballets, and whoever they are. Then the safety measures you actually need to do is that you need to engage with local communities, government agencies, NGOs, and other stakeholders that are actually out to address some of these safety concerns to develop a solution. You also need to participate also in community and safety committees or advisory groups to share information. This is just for you to raise awareness and to make campaigns of actually what you have. In conclusion, ensuring safety in the power system is very, very crucial. You all will agree with me. It is very, very crucial. It is very critical, and it is your responsibility. It is my responsibility. That involves understanding and managing risks, identifying hazard, know that I am not supposed to carry out unsafe act. I am not supposed to experience unsafe or to do something in an unsafe condition, and incidents and accidents can occur when you fail to keep this. So by implementing comprehensive safety procedures, safety measures, safety mitigations, or risk mitigations, you are adhering to regulations and fostering a culture of safety awareness. We can significantly, when I say significantly, I mean significantly, reduce the likelihood of accident and protection, both personnel, environment, and even the public from incidents that are related to electricity. So through continuous training, like we are doing, regular inspection and application of the best practice, don't cut corners. We can create a safer working environment that not only prevent harm, but also promote efficiency and reliability in the power system operation. Thank you very much. I remain my humble self, Olusegun E. Olani. So I am now open to take your questions. Okay, I have a question in the chat room. If you have any question, you can also drop it in the chat room. But if you want to ask, we can actually ask you to unmute and speak. So is there anything like accident report, or it is basically incident report? So basically, we do have accident report. We have accident report, we have incident report, we have investigation report. So when we talk about accident report, is you giving us the details of what has transpired in the accident. Remember, I said there is a difference between accident and accident. And accident can fall under incident. Near miss can fall under incident. But a near miss cannot be called an accident. So it is an accident because it has caused damage to either the equipment or it has caused damage to somebody. That is why we call it accident. But if it doesn't cause damage to the equipment, and it doesn't cause damage to the environment, and it doesn't cause damage to the person, it is called a near miss. So if you want to tell us what actually happened, it is called a report. Now, there are different ways at which you present this, and that is different from what the organization or the individual wants to give. There are steps to all these things. You tell us if you want to give us an accident report, there's a way, there is a methodology that you use in order to give report. Then if you want to give an incident report, there is a way, there is a method that you give. Now, these things, for those of us that have even visited a police before, when they want to ask you for your report, there's a way they do it. And how do they do it? They ask you for your name. They record the time that you come to report, and they ask you the date that maybe what happened you want to report. They will ask you some of these things. So that is accident report. So if it is something that actually happened and maybe your organization needs to take note, there should be a record for it. You record that, okay, so day there was a near miss that happened, this, that. So there is a report, there is accident report, there is incident report, there is investigation report. Investigation report is after we have checked the accident report or the incident report. We now check it. We saw, okay, this is your story. We will now carry out investigation. What actually led to this accident? What led to this incident? So on the course of this, what we are actually doing is what we call investigation. So at the end of the day, what we are going to present, the document we are going to present is what we call investigation report. Thank you very much for your question. Do we have any question in the group or on the call? Any question? If you don't have question, it means I didn't say anything all through. Okay, Emeka, you can go ahead, sir.
Okay, sir. So still on this reporting, sir.
Yes,
So
sir.
there was this a scenario that I want to liken here. So there was an installation, a solar inverter installation. So what happened is there was a fire accident, and then our attention was called to it. So I went to the site, and then I took photographs and videos of everything. So they said I should prepare a report on this accident. So now discuss with the HSC department. So what they gave me was an incident reporting document, asking me to detail or to give in details what I suspect to be the cause of this, fire and all that. And I was not there, so I just, in my own self-explanation, I was able to put out one or two what could cause this incident. So that was what I was now asking: should it be an accident report or an incident report? Okay, sir. So that's my question.
Okay, now, if they gave you an incident report, remember I said something that, okay, and remember the definition I gave as regards incident and accident. Incident,
Yes.
I said you can have a near miss and you can have an accident. Why accident is something that has happened. Now, for example, if you're giving a document as incident report, now you are going to categorize what has happened as either near miss or incident. I will expect that that form should have either a checkbox where you have it is an incident, but under the incident, you have a box that will tick, okay, this is a accident, this is a near miss. So, but actually what they gave you to do is actually investigation. What you were asked to do is investigation. And that investigation, every organization has some peculiarity with them. And the reason why I say there is always a peculiarity is because The document that is being used in company A is different from the company that is used in company B. So the paper that is being given to you, and they are asking you to say what is likely to happen. Already you have started carrying out investigation, because for you to carry out the investigation, you need to say, okay, there are some incidents that will happen, or there are some accidents that will happen that you don't have any evidence of what could have caused it. So what you will now do, okay, now last year, I think, oh no, not last year, 2 years, I think I teamed up with with the Lagos State Safety Commission, and we went to a particular facility around the Marina axis. There's this fire incident that always occur in that structure, in that facility, and it became an eyesore. And they were now like, the Lagos State Safety Commission now said, okay, let's carry out investigation on this particular thing. And they carry out the investigation, and this investigation was, what was presented will be the investigation report. But if you're an accident happened or an incident happened, and you're asked to say what could be the source or what could have caused this fire incident, that is investigation. But if you're asked to say what happened, okay, as I was going, I was carrying petrol, or I was carrying diesel, or maybe, okay, there was a cable that breached and that led to the fire. That is an accident report. That's an incident report. But now, okay, what do you think must have led to that accident? What do you think must have led to that incident? Okay, you can say that, okay, there was a break of this cable in some places at this particular location. Now, has there been a report that there was a break of this insulator from this cable? Yes, there has been a report. So what you are just doing is actually investigation. So the moment you start going above telling the story of how the fire happened, you are carrying out investigation. And when you carry out investigation, you now you give your recommendation. And when you give your recommendation, there is mostly what we do is that when you give recommendation, you tie it to deadline to be sure that these things are put in place. And you do that so that future occurrence are not going to happen again. I hope I have answered your question. If I have not, you should let me know. Then do we have another question? Do we have another question? Okay, then, if we don't have a question, before I come back to this place, I want us to watch a video, please. Don't go. I want us to watch a video. And I'm going to share my screen. Sure. Okay.
Hello, my name is Bill Hoddle. I work for United Power. Me and a few co-workers have put together this high voltage demonstration trailer to show you guys the dangers of high voltage and the damage it can do. 10 years ago, I was electrocuted working in an underground switch cabinet like this here. Normally, the bottom of this cabinet is dead, the top is energized. We crossed the conduit, we didn't mark in and out, so when we energized it, the bottom became hot. My mind was elsewhere. I was thinking about going camping and four-wheeling. I did not check voltage, I didn't have ground, I didn't test. I reached in the bottom of this cabinet when I saw a loose bolt and I went to tighten it. And I took 7,200 volts to ground at my hand and wrist. Came over your internal organs. The The hard hat is for accidental in the equipment if you can, or if you're in lethal. If you have to get out, we want you to stand in the doorway and jump out and land on both feet. We call it bunny hop. We want you to hop away as far as you can, as safely as you can. If you can stay in the vehicle.
Okay, thank you very much for watching. I just wanted you to see what could happen if you fail to actually follow safety protocol. But let me close with this. I'm going to show you a video of how to carry out CPR, the first aid that you are supposed to give to somebody who is either has electric shock, what you need to do. So I'm going to share my screen again. And I want you to please watch and listen. It's not a long video, it's a very short one.
In this video, you'll learn to administer first aid to a person who's been electrocuted. Before touching the victim, always turn off the source of the current, either by pulling the plug out or by turning power off by a switch or circuit breaker. There are 3 possible scenarios to consider depending on the condition of the victim. Scenario 1. The victim is conscious. Check their skin for any signs of burns at the entry and exit points of the electrical current. Wet any burns under running water for at least 5 minutes or until the pain has subsided. Call the emergency services in all cases, as the electrical current may have caused internal injuries. Scenario 2. The victim has lost consciousness but is breathing normally. Put them in the recovery position. Alert the emergency services. Apply cold compressors to the burns until medical help arrives. Scenario 3. The victim has lost consciousness and is not breathing. Alert the emergency services. Start cardiopulmonary resuscitation.
We cannot hear you, sir.
Oh, sorry, my mic was muted. And so I say thank you very much. It's just for you to actually see how to carry out. Can you hear me now? Okay, thank you. So I said that was actually for you to be able to know how to carry out a basic first aid to someone, maybe a colleague who is actually at your place of work, and maybe who is who experienced shock, or maybe have if it's not serious, and you need to actually reach out. So for those of us, if there is no more further question, you can actually follow me on LinkedIn for if you have further questions and you really want to ask. And thank you very much. I don't know if there's anything we can say, but I don't know if the feedback form has been sent in the link. If the feedback form has been shared with us on the platform. And if there is none, If we don't have any, then maybe I will need a comment from one of you before we round up. So I think others are not here. I can't find David on the, okay, Engineer Yusuf is on the call. So do we have the training feedback?
Not yet, sir.
Okay. Oh, so how do we get the feedback?
That will actually what we plan is after the general training, then
Okay.
the feedback form will now be shared with all participants so that we can. It's actually an avenue for us to improve against the next year training.
Okay.
So
Okay,
we actually want it to be a robust feedback.
okay,
So
so
then
I
that
think I will see you, I will call you much later, then we'll talk. Then for this, I will be sending the slide to us, and then we